Hello my dear students, today we are going to see one more topic in our subject mechanics of solid. So today's topic is buckling of column. Once again I will repeat it, buckling of column. So this topic comes under unit 1 as you know. So actually our unit 1 is a little lengthier than other units because in unit 1 we have to learn all the basics of our mechanics of solid. That's why it is little lengthier, understand? So don't get bored. Each and every topic is very important and same way very interesting, understand? As you know, my name is Sudhir Kumar, a lecturer in mechanical engineering from GEMS Polytechnic College, Aurangabad, Bihar. So today we are going to see some topics related to buckling of columns. First we will see what is buckling of columns and we will see what are the essential terms or what are the essential points which we must know about the buckling of column. So let's see what are the content which we have to cover throughout our lecture. So today's content is columns and struts, buckling load, effective length or equivalent length of column, slenderness ratio, long column, short column. In another word, if you will see, we have to know what is column and strut, what is buckling load, what is effective length, or effective length is also known as equivalent length of column. Then we have to see what is slenderness ratio, what is long column and what is short column. So throughout this lecture, we will see all these three topics, understand? First we will start with first topic, column and struts. That means we will know what is column and struts. Okay, let's see our first topic. So what is a strut? See, I have written very simple definition for you guys. If you will remember these topics or this definition, surely you will be able to write in your examination. So what is a strut? Any structural member subjected to compressive load is called as a strut. Understand? Any structural member, that means not a particular structural member, any structural member, it can be any structural member, but it must be subjected to compressive load in any position such as horizontal, vertical or inclined is called as a strut. Or if you will see the example of a strut, member in a truss. If you will see member in a truss, that is known as a strut. We will see all diagram also and picture also what is a strut, but you have to wait. First we will see the definition, because once we get clear concept about the definition theory part, then we will see the practical what is strut and column, understand? So I hope you must have understand strut. What is a strut? Any structural member subjected to compressive load. It may be horizontal, vertical or inclined, understand? It's called as strut. If you will see or if you will talk about the topic column, this is column, this is column. If you will see what is column, then see vertical structural member subjected to axial compressive load are called column, or we can say that vertical strut is known as column. So if you will see example of column is pillar between the roof and floor. Already you have seen that. If one building is there, suppose that one building is there, so these all are the pillar ना, understand? Pillar between roof and floor. ये हमारा जो फ्लोर हो गया और ये हमारा जो रूफ हो गया, इसके बीच में हम लोग जो पिलर देते हैं ना ताकि ये विथ स्टैंड कर सके, उसी को भी हम लोग कर सकते हैं कॉलम। समझ में आ गया? चलिए हम लोग नेक्स्ट देखते हैं डायग्राम कि होता क्या है। Now we will see practically diagram of column and strut, understand? So this diagram is for column, as I told you, जैसा आपको हम बताए हैं बिल्डिंग के बीच में क्या है, छत और रूफ, छत हो गया और नीचे फ्लोर के बीच में जो हम लोग डालते हैं पिलर, उसको हम लोग क्या बोलते हैं, कॉलम बोलते हैं। और स्ट्रट किसको बोलते हैं? जो कि ट्रस में पाया जाता है, उसको हम लोग क्या बोलते हैं, स्ट्रट बोलते हैं। ये आपका स्ट्रट का डायग्राम हो गया। यदि एग्जाम में भी पूछे तो आप ऐसे ड्रॉ कर सकते हैं डायग्राम। समझ में आ गया? ये आपका स्ट्रट हो गया, ये आपका क्या हो गया, कॉलम हो गया। तो कंफ्यूज मत होइए कि क्या स्ट्रट है क्या कॉलम है। पहले आपको क्या है, डिफिनीशन जानना अति आवश्यक है। यदि आपका थियरी पार्ट क्लियर होगा तो आगे भी आपको समझ में अच्छी तरीके से आएगा। तो पहले आपको थियरी पार्ट क्लियर करना है, जैसे कि आपको पता है व्हाट इज स्ट्रट एंड व्हाट इज कॉलम। So once you get clear concept about what is a strut and column, then you can proceed to diagram. So diagram is also essential because 50% of your marks will contain diagram and 50% you will get from your theory parts. So don't leave diagram. Understand? Don't give up diagram. Diagram is very important. So this is column and this one is a strut. Now we will see what is buckling load. बकलिंग लोड होता क्या है, जब भी किसी पे बॉडी पे किसी भी ऑब्जेक्ट पे यदि हम लोग लोड डालते हैं तो उसका शेप थोड़ा सा चेंज होता है। समझ में आ गया? उसको हम लोग बकलिंग लोड बोलते हैं। बकलिंग, उसको बकलिंग बोलते हैं। और जो लोड इसके लिए रिस्पॉन्सिबल होता है उसको क्या बोलेंगे हम लोग, बकलिंग लोड बोलेंगे। व्हाट इज बकलिंग लोड? वी विल सी डेफिनेशन। द मिनिमम लिमिटिंग लोड at which the column tends to have lateral displacement or tends to buckle is called as buckling load. If we will see, buckling load is also known as crippling load or critical load. So if in your examination they will ask what is crippling load or what is critical load, don't get confused, because crippling load, critical load and buckling load all are same only. Understand? Once again I will repeat the definition. Please focus on the definition. The minimum limiting load, as I told you, the minimum limiting load at which the column tends to have lateral displacement. It should contain displacement. Without displacement, no buckling load. Understand? No buckling. So the minimum limiting load at which column tends to have lateral displacement or tends to buckle. Buckle means change in shape, is called buckling or crippling or critical load. And the second point says like this: buckling takes place about the axis having minimum radius of gyration or least movement of inertia. Understand? Second point is very important. If you will solve numerical problem, then second point is very important. Buckling takes place about the axis having minimum radius of gyration or least movement of inertia. So if you will see one more thing, what is safe load? What is safe load? Safe load is equal to buckling load divided by factor of safety. Sometimes in your examination they will ask this point in your numerical, what is safe load? Because whatever we will design in engineering mechanics or in mechanics of solid, we must know what is safe load for any strut or for any column, for any structural member. So what is safe load? Safe load is equal to buckling load divided by factor of safety. Understand? This formula is very important, and once you write the correct formula, at least you will get 50% of your marks. Understand? So you must know what is safe load. What is safe load? Buckling load divided by factor of safety. Now we are going to see what is effective length or equivalent length of column. This is very important during solving the numerical problem, because always they will give the normal length, but you have to calculate effective length. Why? Because when we will use the formula, their effective length value is given. Understand? Effective length dimension will be given. Effective length will be inserted in the formula. So you must know what is the effective length for all the conditions. Understand? So there are many types of effective length or for different conditions, like hinged, fixed column, fixed hinged, fixed or free. So these are the conditions. So you must know what is effective length. So what is effective length? First we will see definition. Effective length or equivalent length of column is defined as the distance between the two successive inflection points. That means point of zero bending moment. Many times in your examination they will ask in 1 mark questions, what is successive inflection point? That means you must know point of zero bending moment. Bending moment will be zero, understand, throughout the point, understand. So these are the conditions, support condition for effective length. These are the formula, understand. This formula only you have to use in your examination, very important. फर्स्ट वन इज बोथ ends hinged. यदि दोनों तरफ दोनों हिंज्ड रहेगा उसका लिए हमारा क्या रहेगा, इफेक्टिव लेंथ किसके बराबर हो जाएगा, लेंथ के बराबर हो जाएगा. If both ends are hinged then our effective length will be equal to original length. But if both ends fixed, यदि दोनों एंड फिक्स्ड रहेगा तो हम लोग इफेक्टिव लेंथ क्या हो जाएगा, लेंथ बाई 2. उस लेंथ को आधा कर देंगे तो मेरा क्या हो जाएगा, इफेक्टिव लेंथ हो जाएगा. ये सारा चीज हम लोग जब न्यूमेरिकल सॉल्व करेंगे कॉलम पे तो हम लोग देखने जा रहे हैं, इसीलिए आप लोग हड़बड़ाइए मत. कीप पेशेंस, वी विल सी ईच एंड एवरीथिंग इन डिटेल मैनर. Why I am giving you the theory part? Because theory part is very essential. Though we get more knowledge from the practical parts, but without theory parts we will not able to understand what is going on. That's why we are saying what are the support condition, understand, and what will be the effective length. So जैसे कि हम लोग देखे, यदि दोनों एंड यदि हिंज्ड रहेगा तो मेरा इफेक्टिव लेंथ के बराबर हो जाएगा, और यदि मेरा दोनों एंड फिक्स्ड रहेगा तो इफेक्टिव लेंथ हमारा लेंथ का आधा के बराबर हो जाएगा. और यदि बात करें वन एंड फिक्स्ड रहेगा और अनदर हिंज्ड रहेगा तो मेरा जो इफेक्टिव लेंथ हो जाएगा L/2 हो जाएगा. समझ में आ गया, ये फॉर्मूला है. और यदि मेरा एक एंड फिक्स्ड रहेगा और दूसरा फ्री रहेगा तो मेरा इफेक्टिव लेंथ मतलब 2L के बराबर हो जाएगा, मतलब लेंथ का दुगुना हो जाएगा, अंडरस्टैंड. If both ends are hinged then LE will be equal to L. If both ends are fixed then LE will be equal to L/2. If one end is fixed, other end is hinged, then LE will be equal to L divided by √2. And if one end is fixed, other ends are free, then LE will be equal to 2L. That means double of length. Understand? Now we will see what is slenderness ratio. This is also very important. In 1 mark questions they will ask what is slenderness ratio. So just they will give the formula, you have to select from the formula which formula is the correct one. So if you will see the definition of slenderness ratio, it is defined as the ratio between the effective length of the column and its minimum radius of gyration. Listen my dear students, it is very important, understand. Then sometimes they will ask you what is the symbol for slenderness ratio. So slenderness ratio is always denoted by the letter lambda. Actually lambda is the Greek letter, but we are all using all throughout our universe, throughout our world. So what is the symbol for slenderness ratio? Lambda. You have to always keep in your mind. And lambda will be equal to LE divided by K. LE is effective length or K is minimum radius of gyration. Understand? These things you have to always keep in your mind. What is lambda? What is LE? What is K? Suppose that if you will remember only the formula lambda is equal to LE divided by K, then easily you can write the definition of slenderness ratio, because the definition comes from the formula and formula comes from the definition. If you are able to write the definition, then you must be able to write the formula, and if you are able to write the formula, then no one will stop you to write the definition of the particular topic. So what is slenderness ratio? Slenderness ratio is the ratio between the effective length of the column and its minimum radius of gyration k. That means lambda will be equal to LE divided by k. LE is effective length and k is radius of gyration. Now we will see what is long column or short column, because already we have seen what is column and what is strut. Now we will see in column there are two terms, one is long column and one is short column. So we have to see what is long column and short column. So what is long column? The column that fails primarily due to the bending stress and whose slenderness ratio is more than 120, or whose length is more than 30 times the diameter is called as long column. Understand? Then what is short column? The column that fails primarily due to the direct stress or whose slenderness ratio is less than 30 or whose length is less than 8 times the diameter is known as short column. Listen my dear students, only 2 points you have to focus here. First one is slenderness ratio is more than 120 in long column, but slenderness ratio is less than 30 in short column. Then second point is, first point here my dear student, this one. Second point is this one. Length is more than 30 times the diameter. Understand? Length will be more than 30 times the diameter. This point is important, but in short column length will be less than the 38 times the diameter. Understand? Only 2 points you have to remember. First one is slenderness ratio is more than 120 in long column, but in short column slenderness ratio is less than 30, but length is more than 30 times the diameter in long column, but length will be less than 8 times the diameter in short column. Understand? Now we will see what are the difference in long column and short column. When the length of the column is more as compared to its cross-sectional dimension, it is known as long column. That is absolutely right. But when the length of the column is less as compared to its cross-sectional dimension, it is called as short column. Already the definition or difference is given by formula also. See here, less than 50, greater than 50. Everything is a slenderness ratio is here greater than 50. Here slenderness ratio is less than 50. This is slenderness ratio. Remember, lambda is equal to LE by K minimum. K minimum is radius of gyration should be minimum. Then L is equal to effective length, D is equal to least lateral dimension of the column, and K minimum is equal to radius of gyration, minimum radius of gyration. Already you know these 2 points. Understand? So now we will see the summary, what we have learned throughout our lecture. I hope you all must have got a clear concept about the following terms, such as column, what is column and struts, what is buckling load, what is effective length or equivalent length of column, what is slenderness ratio, what is long column, and what is short column. Understand? But if you want to gather more knowledge or more essential knowledge about the particular topic which we have covered throughout our lecture, then you can refer these 2 books. First book is Strength of Material by Dr. R.K. Bansal, Dhanpat Rai and Sons publication, and second book is Mechanics of Solid from R.S. Khurmi, and it comes from Eastern publication. So if you will read these 2 books, then you will get more knowledge. Understand? As I told you always, my dear students, don't depend totally on the video lecture. Please go through the books also. Understand? And try to write all the topics, each and every topic in a notebook, because most of the students are getting clear concept by writing down on their notebook. So don't forget these things, understand? So I hope you must have got a clear concept about the topics which we have covered throughout this lecture. So this was our lecture number 16, buckling of column in mechanics of solid subject. Once again I will tell you, my name is Sudhir Kumar, a lecturer in mechanical engineering from James Polytechnic College, Aurangabad, Bihar. Thank you.